Okay, hello everyone. So welcome back to my YouTube channel. So today in session, we are going to learn something about earthquake load calculation. Okay. So basically earthquake load is a kind of load which is acting in the ground. Okay. So which can affect on your building. Okay. So your building can horizontally be tilted because of earthquake load. So what are the factors which we need to consider when we are going to calculate the earthquake load? Those we are going to see in today's session. So we'll learn something about that. So first of all, we have calculated these things, or we have write these things according to the IS 1893/2002. So this formula is for the you can say earthquake load. VB is equals to AH into W. So where your AH is nothing but the seismic coefficient and W is a seismic weight of building. So AH is seismic coefficient, which is based upon the zone factor, importance factor, and response reduction factor, which we are going to learn in brief, in detail, according to IS in a very short manner. Okay, so the point is, what is your seismic weight of building? So seismic weight of building is nothing but the self weight of building, or the load which are coming on the building vertically, which will resist the earthquake load. Okay, so these are the kind of load which are going to resist the earthquake load which is coming in the lateral direction. The earthquake load comes in the form of waves in the ground, either in the x direction or in the z direction, if you are considering y direction as a vertical one. Okay, so ah again we can calculate as per this formula, that is zi by 2r into sa by g, where your z is nothing but the zone factor, I is importance factor, r is response reduction factor, sa by g is your spectral acceleration. Okay, so zone factor depends upon in which area your building is been constructed, in which zone your building is going to be constructed. Okay, so first of all, we will see zone factor, which is denoted in the IS code as per the zones. So I'll show it to you. So this is your zone factor. Okay, so which is given in the IS table, or you can say IS code table number 2, clause 6.4.2. So seismic intensity, nothing but your Z, okay, and which is considered upon the intensity, that is low, moderate, severe, very severe. Some areas are there in which earthquake come in a moderate manner, so the values are calculated based upon the intensity. So low, moderate, severe, very severe. You can see that there are four IS codes. Actually, previously there were 5 IS code, but one is now eliminated from it. Okay, because very low was not possible. The earthquakes which are coming, their intensity is ranging from low to very severe. Okay, so now we will go for the next factor, that is importance factor. I will show it to you. So this is table number 6, which is given in the IS code. It is for the importance factor. Okay, clause 6.4.2. You can read that clause. Now you can see that important factor depend upon the importance of building. If your building is highly important, that is like community buildings or such as hospitals, schools, monumental structures, then the importance factor will be ranging from 1.5. And if it is all other buildings, so you can call it as non-important buildings or residential buildings, these are also important, but the capacity of building, or how much people that building is carrying, that also important. So hospitals, you can consider that this is your important structure. Now all other buildings means residential or some unimportant buildings, which are, we have to consider the factor 1. And this is given by the IS code, so nothing we are going to consider by our own mindset. So it is been given in the IS code and we are going to consider according to that. Now the third important factor is response reduction factor. So we will learn something about that. So you can see that this is your response reduction factor, which is given in this table, table number 7. So you can refer IS 1893, from which I have calculated this, or you can say this is based upon the IS code. So tables are given there, so you can read from that. Now, building frames, it depends upon the type of frame, which kind of frame you have used for the construction of building. Like if it is ordinary moment resisting frame, the factor will be 3. If it is special moment resisting frame, the factor will be 5. So the frame will remain same based upon the grade of concrete. They have categorized it as a ordinary or special one. If you are using a good quality of concrete or higher grade of concrete, then you can consider it as a SMRF, that is special moment resisting frame. And if it is ordinary concrete, you can call it as a OMRF, that is ordinary moment resisting frame. Okay. So now there is also consideration of shear wall, that is shear wall with OMRF, shear wall with SMRF. These are also the consideration. If you have constructed a building with the help of shear wall, or there is a shear wall in your building, so that time you can consider this shear wall factors as well. If your building is a steel frame, then that time you can consider the steel frame as well. So these are many of the things based upon which you can calculate the factor, that is response reduction factor. Okay. So we will move with the next factor. So now Z, we got it from where we are calculating it. We know importance factor now. We know response reduction factor. Now what does this SA by G and upon which factors it depends? So now we will learn something about that. Okay. So you can see this is your SA by G factor, or SA by G as per IS has been given in this way, that it depends upon two factors, that is soil type. One is soil type, which kind of soil is used for the construction, or which type of soil is there under the construction. Okay, whether it is a hard soil, whether it is a medium soil or soft soil, based upon which SA by G will be calculated. And the second factor which we need to consider is the time period for which the earthquake load is going to act upon that building. So that time period also matters. So how we can calculate it, this time period, because soil type we came to know from the you can say when we will calculate the bearing capacity on the site, on site we will get these values, but we must know what is the time period. So time period we can calculate based upon two factors. Okay, whether it is a concrete frame, whether it is a steel frame. Okay, so that we can calculate again from the same IS code. I will show you that formula as well. So the fundamental natural time period, that is the time which is considered there, we calculate it from this formula, that is 0.075 h raised to 0.75 for RC building. Okay, page number 24, IS in which it is mentioned, that is page number is 24. 0.085 h raised to 0.75 for steel frame building. Okay, what does this h is? H is nothing but the height of building in meter. Okay, so you have to consider this height of the building, and this factor is for the time period. Once you will get all these values, you can put these values in that formula. Okay, we will see that. Once we calculate zoning factor from the IS code, importance factor, response reduction factor, and spectral acceleration, we will keep all these values in this particular formula, and we'll get, because 2 is constant one. So if we'll calculate all these values and if we'll put these all values in this formula, we'll get HAH, that is seismic coefficient. Okay, so AH is also given in the IS code. If you want to see that, so I will show you. So you can see that AH is equals to ZI by 2R into SA by G. This formula is given also here. So you can see that this formula based upon which we are going to calculate all these values. Okay, so I have written over there. So you can cross check it from the IS code. So now once we will get all these values, okay, so we can put these values in this formula, that is AH. Now we came to know. Now seismic weight is nothing but the weight of building you have to consider, which are, you can say, the vertical load acting on the building, that also going to resist the load which is acting on the building in a lateral direction. So that we need to consider in the form of this W. So we can find out this VB. VB is nothing but the earthquake load or the horizontal shear. Many of the terms we can denote it for. So VB we can calculate according to this formula. So this is how we are going to calculate the earthquake load as per IS 1893. So I hope you guys have taken some good knowledge from my side in today's session. Hopefully we'll again take some important sessions based upon load calculation in my next videos. Okay, thank you.